Hi, my name is Emilee and this is my Jack and the Beanstalk systems model designed for foundation year students. I created this using recycled and sustainable materials, and it includes two systems, a pulley system and a pneumatic system. The aim of this model is to bring the story to life in a hands-on, interactive way that helps children understand how movement and forces work in real life. I chose Jack and the Beanstalk because it supports early learners to engage with story sequencing, problem solving, and imaginative play. It's a story they often already know, which helps them feel confident when experimenting with different parts of the model. Using this diorama, it links directly with ELF Outcome 4 as children become confident and involved learners through hands-on engagement with systems, prediction, and trial and error thinking. It also supports Outcome 5 because children communicate ideas, ask questions, describe what they see happening, and use language to explain cause and effect. This is my pulley system. Jack is attached to a piece of string that travels up and over the front of the beanstalk and inside the tube. The string loops over a chopstick which acts as a pulley axle. I added an old perfume bottle cap to the end of the chopstick to use as a turning handle. When I rotate the handle in one direction, the string winds up and Jack climbs the beanstalk. When I rotate it the other way, the string unwinds and Jack lowers down. The simple system demonstrates how pulleys can change the direction of force and help move objects more easily. For young children, this creates a really clear visual link between their action, turning the handle, and the movement that happens as a result. It encourages them to predict what will happen before they try it. My second system is a pneumatic system, which uses air pressure. I connected two syringes with a clear tubing. When I push one syringe, the air travels through the tube and pushes the cow forward. When I pull the syringe back, the cow returns. This shows children that air can be used as a force even though we can't see it. It introduces early engineering thinking and cause and effect understanding in a simple, hands-on way. It also links nicely to the storyline where the cow plays an important role in how the adventure begins. I use mostly recycled materials, a shoebox, cardboard boxes, toilet rolls, scrap paper, a perfume bottle cap, clear tubing, syringes, and a chopstick. I joined the materials using glue to stick the paper to the cardboard and sticky tape in areas that needed flexibility. Using these recycled materials models sustainable practices for children and also shows them that creating designs can happen with simple everyday objects. I would use this model during a technologies learning experience where students investigate how movement works. Children could take turns operating both systems while predicting what will happen and then testing their ideas. I would also use it to support story retelling where children sequence events, explain cause and effect, and experiment with different ways Jack and the cow could move. This encourages oral language, imagination, and collaboration. This also supports the ELF by building communication, problem solving, imaginative thinking, and early design understanding. For my design process, I followed the steps from class. I explored different systems like pulleys, pneumatics, levers, and cams, and chose the two that best connected to the story and were achievable with recycled materials. With designing, I sketched the layout and planned how the systems could operate independently without interfering with each other. I also planned where the students' hands would go so the systems were easy to operate. With producing, I built the base first, then added the beanstalk, cottage, and the characters before installing the system. I tested each mechanism before gluing it permanently. I worked in stages so I could troubleshoot as I went and made sure the model was stable and balanced from all angles. I tested the model multiple times to ensure both systems moved smoothly and were easy for a child to operate. If I were to improve it, I would add a light-up golden egg using an electrical circuit to introduce a third system. I considered safety by smoothing all cardboard edges, ensuring no pieces were loose, and keeping the syringes air only for safe classroom use. This model would always be used with supervision so that students operate the systems carefully and safely, especially when turning the pulley or pushing the syringes. This diorama supports children to explore movement, force, storytelling, and early engineering through a hands-on, engaging learning experience.